Okay, here we go with assignment 8.2. So this is lesson 2, where you're going to find the most of the information that pertains to this lesson on our formula sheet is if you flip to the second page, most actually of that information is going to be found right here at the very bottom of this, right here. This is where we're looking. So in case you can't quite see it on my board, here's in essence the highlights of what we have. Okay, first is some symbols. This is the Greek letter mu. Mu stands for the average. Okay, another word for the average is the mean. Okay, so that represents the mean or the average of something. Next is another Greek letter. This is lowercase sigma, and this stands for something called a standard deviation. And a standard deviation is kind of a rough gauge of how spread apart are the different pieces of information from a set of numbers. So how far are they from each other? Okay, now this curve, this empirical rule or curve that they are explaining in almost all of these questions. Okay, this is based upon the empirical rule. This is of a normal distribution. And how a lot of these are referring to it is just the curve. Okay, this is the curve that they speak of. This is called a bell shape or a normal distribution. All right, so we have this bump up in the middle, it flattens out, and we have this bottom. All right, so putting things on this quote-unquote curve. Right smack dab in the middle is mu, or AKA the average of something. All right, so think of these as the heights of people. Most people are average, thus the bump is really high. So the average height of students, most people are average, thus the bump is really high. Now there's obviously people taller than that average. Okay, and so we draw 3 lines to the right, and these are the quote-unquote standard deviations. So 1 standard deviation, 2 standard deviations, and 3 standard deviations above the average. Okay. I'll give you an example of what this kind of means here in just a moment. And then we can have people shorter than the average. So 1 standard deviation, 2 standard deviations, 3 standard deviations. So a common example that I give is this. Pretend that the average height of students at school is 5'6". That's the average height of students. All right. So 5'6" is your average height. Let's say we have a standard deviation of 2 inches. A standard deviation of 2 inches. So if I'm talking about standard deviations larger than that average, 1 standard deviation would be 5'8". The next standard deviation would be 5'10". And then the next standard deviation would be 6 foot. And then you can take standard deviations away from that average as well. So 1 standard deviation, aka 2 inches below the average, would be 5'4". And then 5'2", and then 5 foot. And so that's a distribution curve. Okay, now, what is the empirical rule and what's the technicalities and the really important part of this? The really important part about this is the percentages that fall into these bars. So for instance, if I'm talking about this first bar, that first bar is 34% of the entire curve. So if I ask what percentage of students are between 5'6" and 5'8", What percentage of students are between 5'6" and 5'8"? You could say 34%. 34% of the students are between 5'6" and 5'8". The next part of the curve is 13.5% of the entire curve. So what percentage of the students are between 5'8" and 5'10"? Well, that'd be 13.5 are between 5'8" and 5'10". And then ultimately, knowing multiples of these things, you could ask a question: what is the what percentage of the population is somewhere between 5'6" and 5'10"? So 5'6" to 5'10" would be both of those. And so that'd be 47.5%. Okay, continuing on with the important numbers. This next bar, and is smaller, this is 2.35%. And then that last little sliver, I'll write it in orange. Okay, everything going out that way forever and ever is 0.15%. Okay, these exact same numbers are symmetrical. So these percentages are the exact same on the reverse side. So that's 34, that's 13.5. The next is 235. And then last but not least is 0.15. And so now what's going to be asked of us in a lot of these questions is, given a situation where we know the average and the standard deviation, they will ask us questions in reference to this. Like, what percentage of the population is from 5'2" to 5'8"? 5'2" to 5'8". 5'2" to 5'8", okay, would be this 13.5, this 34, and this 34. That's everything from 5'2" to 5'8", and so that would be 81.5%. Okay, so let's go ahead and talk about these. Ooh, there's one more. Sorry. If anybody asks for what is average or normal or something like that, if something is quote unquote average, or if they ask about a standard deviation, let's get another color here. That cutoff is 2 standard deviations below to 2 standard deviations above. This is considered to be average. So it's the average plus and minus 2 standard deviations. So this is considered to be average, right? So in the world of like heights of students, it's average to be 5'2" to 5'10". You would probably be considered tall if you're above 5'10", or short if you're below 5'2". So if, John comes walking along and John is 6'1", we could quantify John as being tall. However, if Billy comes around and Billy happens to be 5'9", 5'9" would be average, because again, it's between 5'2" and 5'10". That would be average. And then, Chuck comes along. Chuck is 5'1". Chuck is 5'1". 5'1" is right there. 5'1" is short. So it quantifies what quote unquote average is. So 2 up to 2 down. Okay, let's take a look at some of these answers. What percentage of the curve lies within 3 standard deviations of the mean? All right, so here's our curve. One, two, three, 1, 2, 3. And so here is our average, right smack dab in the middle. And so we go up 1 standard deviation, 2 standard deviations, 3 standard deviations, down 1, down 2, down 3. They want to be within 3 of the mean. So that means if the mean is the smack dab middle, they want to be within 3 up to 3 down. This is quote unquote within 3. So the percentages that apply to these various bars that would be within 3 would be 2, 3, 5, 13, 5, 34, 34, 13, 5, and 2, 3, 5. So what is within 3? That would be all of those added up. I believe that's 99.7%. And a lot of times they ask that as a decimal, so that'd be 0.997. Here, I don't think they ask. Yeah, what percentage? So the percentage is 99.7%. Okay, same question, but this one is asking for 2 standard deviations. So our curve, 1, 2, 3, 1, 2, 3. So this is the average, 1 standard deviation, 2 standard deviations, 3 standard deviations, 1 standard deviation, 2 standard deviation, 3 standard deviations. And so if our average is in the middle, we want to go within 2. So that's 2 up to 2 down. So the various percentages that apply to these things are 13.5, 34, 34, and 13.5. And that comes out to be 95%. Last but not least, what percentage is within 1 standard deviation? And so that would be 1 standard deviation above the average and 1 standard deviation below the average. So that would be 34 and 34. So as a percentage, that would be 68%. All right, next, they say the mean of 10 and a standard deviation of 1. So our mean is 10 and our standard deviation is 1. So they're going to ask us some questions about this. So our mean is 10. And our standard deviations are 1. So 1 standard deviation would be 11, and then 12, and then 13, 9, and 8, and 7. Again, because a standard deviation is 1. So if this is 10, and a standard deviation is 1, 1, that'd be the average plus 1 standard deviation. So that'd be 10 plus 1, 1. However, if the standard deviation, for instance, is 2, okay, that would be 12. So you don't necessarily go up by 1. You go up by 1 standard deviation. So back to kind of this brief example, notice how the standard deviation was 2 inches. Thus, when I added a standard deviation to the average, it went up to 5'8", not 5'7", because I go up by 1 standard deviation. I go up by 1, 2. Okay, anyway. So here is our situation right here. They want to know what is the probability of selecting a number between 8 and 11. So between 8 and 11 would encapsulate that bar, and that bar, which are 34, 34, and 13.5 respectively. So this would be that 34, 34, and 13.5. And again, I think that's 81.5. Let me check my math on this one. Oh, decimal to 3, decimal places move it 2. So 815. Let me just check that real quick with a calculator right here. So that's 34, 34, 13.5. Yeah, 815. And then as a decimal, that'd be 0.815. Okay, so here we have a mean of 10, standard deviation of 1. So this is going to be the exact same picture as what we just created. So the average goes in the middle. The standard deviation is 1, so plus 1, plus 1, plus 1, minus 1, minus 1, minus 1. We're looking at most 9. At most 9. Oh, what at most 9 means is the top level is 9. So I'm looking for everything at most 9. So 9 is the top level. So it's everything to the left of 9 in essence. So at most 9. So this would be these 3 areas right here, which is 13.5, 235, 015. Straight up 16% as a decimal, that is 0.160. All right, so again, we have an average of 10, standard deviation of 1. Here they want at most 10. So 10 is the most, at most 10. So that's going to be 34, 13.5, 235, and 015. That comes out to be 50 times 0.5. Okay, here between 8 and 12. Okay, so 8 is right here, 12 is right here. So between 8 and 12. Okay, at least 12. So at least means that is the smallest. So the smallest, the least is 12. So it's 12 and on. That's where the decimal gets a little bit confusing when it comes to a percentage, because you have to move the decimal place 2 places. So you got to kind of fill in the 0. Okay, here the average is 140, standard deviation is 10. So the average is 140. A standard deviation is 10. So one standard deviation larger, 10 larger would be 150, 160, 170. And then going down is 130, 120, and 110. All right, so the average, okay? So average is 2 up to 2 down. So this is average. So average is 120 to 160. This is what average is. Okay, this is quote unquote normal in this situation. All right, so if somebody weighs more than 160, that would be heavy, and less would be light. Let's see, where does John come weighing in? John is 115. Notice 115 is below that 120. So John is considered to be light in this situation. Okay, so here we go. The mean is 100 and the standard deviation is 15. I'm going to make this just a little bit wider. So the average is 110. Excuse me, 100. Standard deviation is 15. So 100 plus 15, plus 15, plus 15. 100 minus 15, minus 15, minus 15. So normal is, again, if this is the average, it's 2 up and 2 down. So normal is between 70 and 130. So if you're above 130, that would be considered to be smart. If you're less than 70, that would be considered to be unintelligent. Let's see, Jane comes weighing in at 125. 125 is about there-ish. 125 is below 130, so Jane is considered to be normal.